To set the scene for the movie Gravity, Sandra Bullock and George Clooney are traveling back towards the International Space Station. As they are flying, Clooney positions himself to use his jetpack to propel both of them to the correct location. Once it is the time to slow down, Clooney realizes that there is not enough air in the tank to slow down their approach. Bullock and Clooney collide with the ISS and begin tumbling alongside of it. The astronauts collide with the wing that breaks the tether separating the two of them. The collisions they experience are elastic, conserving all the energy. The impulse from these collisions are causing the change in direction of the momentum. Energy is conserved because there is no loss due to gravity or heat in space. Bullock then gets tangled in the parachute cords coming off the ISS. As Clooney passes by Bullock, she reaches out to grab him. They miss, but she manages to grab the tether that is attached to his suit. Now we will play our scene from the movie Gravity, directed by Alfonso Cuarón, starring Sandra Bullock and George Clooney. The movie was produced by Warner Brothers Picture in 2013.
It's not up to you. You're gonna make it, Ryan.
No!
Steady.
Now we will discuss what went wrong in this scene. As described earlier, Sandra Bullock and George Clooney are flying at the ISS at a constant velocity. As they impact the ISS in elastic collisions, the tether between them breaks, leaving them flying in different directions from each other, but in vicinity of the ISS. Sandra Bullock begins flying towards paracords that came from a Russian capsule that was docked at the ISS at the time. Her momentum that has been conserved through the elastic collisions in a direction away from the ISS begins to stretch the cord that is wrapped around her foot. The paracord is absorbing the energy of Sandra Bullock and at the same time stretching like a spring. The cord stretches to a point where it becomes taut and there is tension in the paracord. This tension in the paracord provides the centripetal force that propels Sandra Bullock in a circular motion about the ISS. The amount of stretch in this paracord directly depends on the K constant of that paracord, which is the paracord type and its strength. With Sandra Bullock's foot caught on the paracord, the friction between the cord and her foot is what provides the inelastic collision. As depicted in the scene, Sandra Bullock is moving in a circular motion about the ISS due to the tension in the cord. This motion moves her closer into the direction of Clooney. George Clooney also has momentum conserved from his elastic collisions with the ISS as well. George Clooney flies towards Sandra Bullock, and Sandra Bullock grabs the tether in an attempt to stop his momentum and save him from flying off into space. This action causes the cord that was wrapped around her foot to begin stretching even further and start to slip off her foot. The force of Clooney and Sandra Bullock is so great that they're about to both slip out of the paracords. George Clooney notices this and unhooks himself from the tether. When George Clooney unhooks himself, he goes flying in one direction and Sandra Bullock goes flying towards another direction, towards the ISS. To summarize what went wrong in this scene, we can say that Clooney did not need to detach himself from Bullock in order to save her. This was because there were no forces acting on Clooney that would cause him to fly away from the ISS like he did. The friction between the paracord in Sandra's boot and her hand and the tether that's connected to George Clooney absorbs the kinetic energy and makes the velocity equal to that of the ISS. When all three objects are traveling at the same speed and in the same direction, they're traveling as one system. There is no outside external net force pushing George Clooney away from the ISS, and therefore the cord should not stretch and he should not fly off in the direction he did. In the following segments, we'll prove what should have happened and how to set this scene up so that it obeys the laws of physics.
Using angles gathered from specific frames and scenes of the movie, it can be seen how the movie attempts to justify these anomalies, as it advocates for a constant rotational motion with angular velocity values reaching 0.035 radians per second. Such momentum would send Clooney floating away at roughly 0.7 meters per second. However, the cause of such behavior in this movie violates Newton's first law, and we can conclude that this rotational motion would have never happened.
Now we will explore what would happen in this scene had the movie followed the laws of physics. As explained in the previous slide, there was no force that would have enabled them to fly outwards into space, as shown in the film. The only motion they had in this scene was the minuscule rotational motion from the tether to the ISS. This can be shown in the following picture. In scene A, Bullock and Clooney are not tethered together, but Bullock is tethered to the ISS and rotating very slowly about the ISS. In scene B, Clooney tethers himself to Bullock, and they are both rotating together, again, very slowly, about the ISS. From scene C, D, and E, they are both rotating very slowly still. In scene F, when Clooney lets go of Bullock, he is shown flying outwards when there is no force enabling him to do so. To explain what would actually happen had this scene obeyed the laws of physics, we will explore Newton's first law of motion. Newton's first law explains that any object will remain still or at a constant velocity unless acted on by an outside force. Since there are no frictional or drag forces acting on objects in space, any object traveling in space will remain at a constant velocity unless it was to be acted on by another force. Had this film obeyed the laws of physics, what we would see is that when Clooney lets go of the tether, he would remain in a constant motion around the ISS along with Bullock and not fly away as shown in the film. To the viewer, once Clooney let go of the tether, it would look like he was traveling with her as if he had never let go of the tether at all. This is what would happen in this scene had this film obeyed the laws of physics. Some extraneous information we want to include in this presentation is a possible solution for Clooney to not sacrifice himself. When he is shown grasping onto the tether, and assuming the film obeys physics and that there is no force pushing him outwards, he could create a force that would pull himself towards Bullock by tugging on the tether. This tugging force would cause him to accelerate slightly towards Bullock, and he would then travel at a constant velocity towards her since there are no other opposing forces acting on him in space. Again, this would happen because of Newton's first law of motion. This would allow Clooney to survive this scene and would not have to sacrifice himself. In summary, this project concludes that the movie Gravity does not obey the laws of physics. By exploring Newton's first law of motion, rotational dynamics, and drawing out free body diagrams, we were able to disprove this scene in the film where Clooney lets go of the tether and floats away due to a non-existent force. Since our free body diagram shows that there were no other forces acting on them during this scene, and that Newton's first law tells us that an object will remain in a constant velocity unless acted on by another force, the only conclusion to this is that the physics in this movie are incorrect. It is believed that the film used clever angles of the action and intense cinematic shots of them to let the audience believe that this scene should be physically correct. Additionally, we were able to find out what would happen if this film were to follow physics in the real world, and to show that he would have remained in the same constant motion and velocity as Bullock, and thus there was no need for him to sacrifice himself.